Chapter 2, Kinematics. First, let's look at the difference between distance and displacement. So for distance, it can be this path from point A, 10 km to point B, or this path, which is 7 km. That's the distance traveled. But for displacement, it's actually the distance measured in a straight line from one point to another point, and also the shortest distance. Okay, let's look at the SI unit is in meters. For both are in meters. However, for distance is a scalar quantity. For displacement is a vector quantity, which means direction is important. Now let's look at the speed versus velocity. So for this cyclist, he traveled from point P to point Q. Okay, he took a long route. However, the displacement is the shortest distance between point P and Q. So for speed is the distance moved per unit time, whereas velocity is the rate of change of displacement. The SI units for both are the same, it's meter per second. Speed is a scalar quantity, velocity is a vector quantity because direction is important. The formula for speed is distance over time taken. For velocity, v is equals to displacement over time. Now, let's look at the average speed. Formula for average speed is total distance traveled over total time. For average velocity, is total displacement over total time taken. Please note that the total time includes wait time or the stop time. Now, let's look at acceleration. The definition of acceleration is the rate of change of velocity, formula given by A equals to v minus u over t. V is the final velocity, u is the initial velocity, t is the time. The SI unit for acceleration is meter per second per second. Okay, there's two types of acceleration. One is uniform and one is non-uniform. Looking at the uniform one, if the object is at constant velocity or not moving at rest, okay, your acceleration is 0. So A is equals to 0 meter per second per second. Now, for positive acceleration, which means the velocity is increasing, so the object is speeding up. For negative acceleration, there's two conditions. Either the object is slowing down, okay, or is traveling in the opposite direction. So another term for negative acceleration, you can use the word deceleration. There are also non-uniform acceleration, which will be explained later. Okay, looking at the graph, there are the distance time graph. The gradient of the distance time graph will give you the speed of the object. So looking at the first scenario, we see that the gradient here is 0. So your speed is 0 meter per second. Now looking at here, the gradient for this graph is constant. So your speed is constant. Okay, now look at this graph. You see that the gradient of the graph increases, and that's why the speed is increasing. For this case, the gradient of the graph is getting less steep, as a result, decreasing speed. Okay, let's look at now speed time graph. The gradient of a speed time graph gives you the acceleration of the object. There are two different cases I mentioned, uniform and non-uniform. For the uniform case, you see that the gradient here is 0, acceleration equals 0 meter per second per second. Same thing here, the gradient for this graph at constant speed, acceleration is 0. So for this one, you see that the gradient is constant, as well as decreasing speed at a constant rate. Acceleration is constant. Now let's look at non-uniform acceleration. You can see that the gradient here is getting less steep. As a result, it is decreasing acceleration. For this case, it's getting steeper, increasing acceleration. So since the velocity is at high, it's getting less steep, decreasing deceleration. In this case, the velocity started off high, getting less steep, so getting steeper. It's actually increasing deceleration. Okay, let's move on to the area under a speed time graph. The area under the speed time graph gives you the distance traveled. So for portion A, this is actually a triangle. You just need to find the area of the triangle to get the distance traveled in A. And to get the distance traveled in all A, B, C, and D, you just need to find the area under all the four portions and add them up together. And that's the total distance traveled in t equals to 50 seconds. Acceleration of free fall, which is also acceleration due to gravity. For an object near the Earth, this acceleration is constant, and the formula is g equals to 10 meter per second per second. And this is a constant. Okay, so free fall only happens in a vacuum when there is no air resistance. So the only force is acting on it is actually its own weight. So if I were to draw the free body diagram, it should look like this. Okay, the direction is downwards towards the Earth. Now, please note that this acceleration is not dependent on the mass or the size of the object, only dependent on the gravitational field strength. So let's look at objects with air resistance. So if it has air resistance, you look at this, the weight and the extra force of air resistance. So air resistance is a frictional force and is a contact force. Air resistance increases with speed, increases with surface area or the size, as well as the density of air. And that's the end of chapter 2.